Lab 5, Choose Your Own Adventure. The goal of this lab is to observe the collision of two objects and understand the principles of conservation of momentum and see whether the collision was elastic or inelastic. I observed two carts, one with a mass of 1.5 kilograms and one with a mass of 4.5 kilograms. The first crate was moving with a constant velocity while the second crate was not moving, and I used tracker to measure the position versus time for the moving crate and stagnant crate before and after their collision. In the end, we find that the final momentum after the collision is equal to the initial momentum before the collision, and that because there was a change in kinetic energy, the collision was elastic. From the momentum principle, F net, or the net force, is equal to dp over dt. Delta p, or the change in momentum, is equal to final momentum minus initial momentum. For a collision, the change in momentum of an entire system is always equal to 0. Therefore, final momentum is equal to initial momentum and the momentum is conserved. For calculating kinetic energy, the change in kinetic energy is equal to the final kinetic energy minus the initial kinetic energy. Kinetic energy is equal to 1/2 times mass times the velocity squared. For elastic collisions, the final kinetic energy is equal to the initial kinetic energy, and therefore kinetic energy is conserved. My visual from tracker shows the two crates. The first crate that is moving initially has a mass of 1.5 kilograms. The other crate, that is 4.5 kilograms, is stagnant in the beginning. After the two crates collide, they move apart from each other with different velocities. My tracker data for mass A shows the change in position over time before the collision and then after the collision. The positive slope represents the change before the collision, and the negative slope represents the change after. My tracker data for mass B shows the change in position over time before the collision and then after the collision. The zero slope represents that there was no change in position over time before the collision, and the positive slope represents the change after. For carts 1 and 2, I have calculated the initial velocities by picking 2 points of position and dividing them by the time interval between those 2 points. As you can see, the initial velocity of the moving cart is 4.5 meters per second, and the initial velocity of the other cart that is not moving is 0 meters per second. The VPython code shows how I have calculated momentum and initial kinetic energy through using the mass given and the velocities found. To calculate the initial momentum, I did the first mass times the initial velocity of the first block, plus the second mass times the initial velocity of the second block. From here, I got the initial momentum to equal 6.81 kilogram meters per second. For carts 1 and 2, I have calculated the final velocities by picking 2 points of position and dividing them by the time intervals between those 2 points. As you can see, the final velocity for cart 1 is negative 1.81 meters per second, and the final velocity for cart 2 is 1.79 meters per second. The VPython code shows how I've calculated momentum and final kinetic energy through using the mass given and the velocities found. In order to calculate final momentum, I took the mass of the first object times its velocity plus the mass of the second object times its final velocity. From here, I got the final momentum to equal 5.4 kilogram meters per second. To calculate initial kinetic energy, I took 1/2 times the mass times the initial velocity squared and got 15.485 joules. To calculate the final kinetic energy, I took 1/2 times the mass times the velocity of the first block squared plus 1/2 times the mass times the velocity of the second block squared. From this, I found the kinetic final energy to be 9.66 joules. The computational model represents the center of the mass of the two balls before the collision and after the collision. In conclusion, from Newton's second law, we can see that in this example, momentum is conserved. Since the collision was elastic, which only occurs if there is no net conversion of kinetic energy into other forms, the kinetic energy was also conserved. Of course, there were some errors in the experiment. Any discrepancies in the final and initial momentum could have been due to incorrectly observing the center of mass for both of the carts on tracker. Any discrepancies in the final and initial kinetic energies could have been due to a small amount of friction force acting on both crates.